Thank you, Markus, for writing the link to the documentation concept. That helps a lot. And as you can see, this one, a moment, you find also the flow you find here on the website as well. I will post it again, this mvp.png. So we can see this simple flow. It's best if you see that as a raw file. You need to click on download, and then you see that full file. I think that helps a lot to understand how the EDC is working. There's another question from Thomas. Question to sample 4. Is the contract offer JSON compliant to the IDS info model? I think we go now to question 4 now, and then we can answer this question. Let's close everything. Close. One, 2, and 3. And by the way, how is the speed? Is it too fast, too slow? Should we more go ahead? We also can write in the chat if you can follow good. Okay, good.
Perfect.
Okay, so we have now 252. Let's go to file transfer, the README, and this is a longer.
Yeah, so this one is the first really more complex sample, because in the 3 previous samples, we always were just using one single connector and always just adding a little bit of functionality to it. In this 4th sample now, we're actually going to spin up 2 connectors, perform a contract negotiation between them, and then also transfer a file between them. So in order to keep this still as simple as possible, the transfer scenario is a rather simple one. So we'll have these 2 connectors running on the same machine, and then we will just copy a file from one folder to another, but within the same file system. So transfer-wise, this is very simple, but of course, this could be other locations, like, for example, a cloud storage then too.
Mm-hmm.
So now, in order to be able to achieve this, that the 2 connectors communicate and that we have the contract negotiation and the transfer, we need to set up a few more things than in the previous samples. So looking here at the sample directory, we see that this time we don't have a single source folder, but we have 4 different modules. The consumer and the provider modules are just containing the build file and the properties file for the consumer and provider connector respectively. So they don't add any code, but we have added the new modules API and transfer file. This API module will be used on the consumer side. So basically we'll just add more endpoints like we did in the previous sample with the health endpoint. But this time, of course, we require different functionality for these endpoints. So in order for the for us as a user to trigger or initiate the contract negotiation and the transfer using our connector, we need to expose API endpoints there that take user input and then start the negotiation and start the transfer process respectively. So if under API, if you open the source folder, we can take a quick look at our new controller. So we're still using a controller like in the previous samples. We're actually also reusing that controller. I think when you open that, you will still see the health endpoint in there. So we're still building on the base from the previous sample, but this time, of course, we're adding 2 additional endpoints. And
the health endpoint, right?
Yeah, that's still there from the previous sample, exactly. And then we have this negotiation endpoint, and below that also the initiate transfer endpoint. And these we can then call as a user so that our consumer will start to contact the provider. And in both cases, what happens in these endpoints is just that the connector builds together this data request, or I think above it's a contract request object, and just stores all information that are important for the transfer or the negotiation. And then, as you see here in line 113, this process manager is the transfer process manager.
I need to open it.
Yeah.
113, right?
Yeah, 13 it was, yeah. So this process manager is the transfer process manager. So that's the system responsible for handling the state machine. And we're just handing over our new data request to that process manager. And after that, we're done. So the process manager will handle the rest in the background. And the same is for the contract negotiation. So we just built together this object holding all the relevant information, and then trigger this in the contract negotiation manager in the other endpoint. So in both cases, we're really just collecting the information and triggering the state machines. So both of these operations could also be performed via an existing control API of the EDC. So we have an extension that offers such an API, but this is more complex than the endpoints that we defined here. And so it requires more complex user input. And in order to keep this as simple as possible, we've created these 2 new endpoints here so that they're easier to use as a user then.
Great.
Yep. So, and this is already everything we did for the API here. Of course, we have the extension class again, but this is just the same as in the previous sample. So we're just registering our controller there. So the API module with this is already finished. We can use this on the consumer side when we build the consumer connector then. And then the next thing we need to create is this file transfer, or transfer file it's called here in the module, for the provider. Because of course the provider on the one hand needs code that can copy the file from one location to the other, but it also somehow needs to set up the data offer. So it needs to register an asset and create a contract definition in order to make this offer available. And this all happens in the file transfer extension. So if you open that in the bottom part of the initialize method, we're starting by creating the policies, the contract definition, and the data entry. So they are starting on line 61. The first thing that we're doing is creating a policy. Now, starting on line 69, we have the method for this. And the first thing that we're doing here is create a permission. So basically, a policy is just a collection of rules that should apply to a certain set of data. And we have in the EDC, but just as well as in the IDS, 3 different types of rules. So we have permissions to allow something, we have prohibitions to prohibit certain actions, and we also have duties or obligations, so actions that a consumer would have to take when using this. But here in this example, we're just using probably the simplest permission possible. So we're just saying that the action is used, meaning that this permission simply allows generally using the data without restrictions. But of course, later on, these could be much more complex. And then once we've built the permission, we create a policy. We give that policy an ID. We add our just created permission to the policy, and we also specify a target for the policy. Now, and this test document is exactly the same thing that we're going to use for the asset ID. So if you look to the method below that in line 92, I think it is, there we're defining test document to also be our asset ID. And that meaning that this policy that we're creating above will target the asset that we're creating here. So and then we see that when we're creating the asset, actually, the first thing that we do is read again a setting from the context. So we'll see that when we're configuring the provider in a moment. Here again, we're using a configuration property so that we can specify where the original file on the provider side lies. So this defaults here to the TMB provider directory, but you might have a text file you want to share on your desktop, then you could just overwrite this via a property. And then next, we set up the data address. So the data address just describes a location of a data. It can either be a data source or it can be a data sink. And in our case of the file here, we're adding the property type and setting it to file, and we're adding the properties path and file name. So basically, with that information available, the connector will be able to find that file and access it. And with that in place, next we're building the asset, which is very simple here because we're adding only the ID, but of course we could add a lot more metadata here. And once we have the data address and the asset in place, we're handing both over to the asset loader. So we've heard already today that we currently do not have an API that can be used to register new assets or contract definitions or so on, but we have this asset loader in here. And this asset loader can be used as a means to persist assets. So by handing it the asset and the data address, it will all be persisted and will be available in our system. So when then the provider connector looks up its own data offers, it will find this asset with the associated data address. And then the last thing that we need to create is the contract definition. So basically a template, how contract offers can look for a certain range of assets. And here again, the first thing we have to give to the contract definition is an ID so that it can be referenced later on. And then we are adding the policy that we created previously as the access as well as the contract policy. So here, just a quick recap, this access policy will be evaluated when a participant requests the contract offers, and contract offers will only be given out or even shown to a participant if the access policy is fulfilled. And then the contract policy, that is the part we're actually also sending out to the consumer that is then subject to the policy negotiation. And in our case, we're just using the simple use policy in both cases. So we're fine with that. And then the last thing that we're setting is this asset selector expression. So this is an expression with which we can define for which assets this contract definition should be valid. And if you scroll to the right a little bit, we see that we're using a simple equals operator there. So we're saying when equals, and then comparing the asset ID to the string test document. And because we define test document as the ID for our asset, this contract definition will exactly be available for one asset, and that's the one that we previously created. And so with these three steps, we now have an asset and an associated contract definition with policies in place. So on the provider side, we're ready now with setting up our data. So once all these three things are in place, the consumer could request this file. But of course now, when the consumer requests the file, the provider also needs to be able to transfer the file, so to copy it to the location specified by the consumer. And that's where we've created this file transfer data stream publisher, the other class in our module here. And if we scroll up to the beginning of the extension, there we instantiate and register it. So this file transfer data stream publisher implements the data stream publisher or stream publisher interface, which is basically just a system responsible for pushing data to a specified location. And we're overriding this here for the file transfer. I mean, we can have a short look at it, but it's really just basic code for copying a file in there. So it reads the source and the destination, and then just uses the standard Java to copy the file. We're registering this with the data, so-called data operator registry. There, all of our stream publishers have to be registered so that they can be found when an active request is processed. Then they will just fetch the correct one for the ongoing transfer from the data operator registry. And in our case, we've just defined that this file transfer data stream publisher is viable for all data transfers of type file. And since in our setup, we defined our data address to be of type file, it will be handled by our new stream publisher. Yes, and
there was one question from Sachin. Can we add multiple different permissions in contract file for data offer? If yes, then how we can add it, like we have a time frame, limited number of use, etc. Usage control options available in IDS Dataspace Connector.
Yeah, so if you scroll down in the extension a little bit back to the policy part there, so yeah, a little bit up, the policy part, so the upper method of the two.
This one?
Yeah, exactly. So here in this policy, we're setting our permission as the permission, but we can also, for example, add a prohibition and or a duty here. So we can also add multiple rules. And then when we're looking at this permission builder there in the beginning, so we're this time just defining the action and saying the action is used. So we just allow the usage without restrictions. But on a permission or any type of rule, you could also add constraints. So you could say the action that I allow is use, but I'm adding a constraint. And then the constraint could, for example, read may only be used in January of 2022 or may only be used 5 times. Then these constraints typically consist of a left operand, operator, and a right operand. And then you could, for example, have something like a very simple example now, the system time is before a certain date or something like this. And of these constraints, you can build together and add multiple to single rules. And then you can again use multiple rules in a policy and therefore build up quite the complex usage policy construct for a single set of data.
Perfect. I think let's go now to the next steps to build a provider and a consumer, right?
Exactly. So we've now defined both the modules that we need on the respective sites. And next thing that we need to do is then create the build Gradle files and the properties files for both our connectors. And this time in the build file, we of course have to add more dependencies than before, because, for example, we need some communication protocol. So we're adding the IDS extension there, for example. Yeah, it should be a little further down there.
Extension, right?
Yeah, if you looked at the transfer file just now, I think if you scroll down a little more, then we get to the connectors.
By transfer extension, right?
Yeah, this is the one that we've, I think, just looked at.
Yeah, great. Let's go to the right. This is the right one.
Exactly. So this is just a part of the code that we've seen in that extension already.
Now we need to configure that, right?
Exactly. So that's the part where it starts with create the connectors. And for these, we start with adding the IDS protocol. So this is this implementation project data protocols IDS. And here we're also adding the whole IDS module for both, because both need to be able to send as well as receive messages. So we're just adding the whole IDS module and thus making the resulting connectors capable of communicating via IDS multipart.
In this case here, we have under consumer, the build Gradle file, and that adds the data protocol IDS, right?
Exactly. And then we see above that we're also adding the control API. So I already mentioned that just now. We're overriding these, so we're using our custom endpoints for triggering the negotiation and the transfer. But we are going to use one simple endpoint from the control API in order to see to get our contract agreement. And that's why we're adding this extension in here. And then the other thing that we've added here is 2 lines above that, the IAM mock extension. So because we will now have 2 connectors that communicate with each other, we of course will need an identity provider, because during the communication, they rely on the fact that they, however that identity provider might look, get information from it. And here we're just providing this IAM mock, which is a mockup that does not rely on any external systems and just returns here's your credential, and the credential is fine. So we're just mocking this in order to be able to have these 2 communicate with each other. Yeah, and then the last thing in line 41 that we add is, of course, the API module that we have just created within our sample, because we want to be able to contact our consumer connector.
Great. This is the consumer side. Now we have to go to the provider side, right?
Exactly. So this should actually look just the same, except for that we're using the transfer file module instead of the API from the sample. But we're also adding the data protocols. We're adding the IAM mock. But then we're adding this new transfer file module here to the provider so that the provider hosts the file once it's started.
Configuration. So let's compare this. Yeah, right. File system IAM API control.
Du fragst du Babylon, weil du es Babylon gemacht hast.
Florian, you have a question?
Oh, apologies. Was I on mute? That was not. I was on hold for a couple of minutes, and I resumed, and I was not aware that I'm unmuted because I was on mute all the time. Apologies for that. Actually, I was talking to my cat, so I'm I'm not at all retarded. I was just talking to my cat.
Okay, great. Okay, so now we have the consumer side configured, the provider side configured.
Exactly, but we still need to adjust the config properties for both connectors. So now we've had the build creator file, but we also have to set some properties here. So at least for one connector, we need to override the port definitely, because they can both run on the same machine. And therefore here for the, let's start with the provider. So here we're not overriding the port, so the provider will still run on the port 8181. But one thing that we need to override, of course, is the first property here, this asset path, because this is the one that's used in the extension to determine where the file that we're hosting is located. So of course, this has to point to an existing file in your system. Otherwise, there will be an error and the file will not be able to be transferred.
Let's do it like that. So LL, TMP, /provider. Now you find here a test document. And so we can have like, I think it's empty as I remember, provider and test document. Oh no, that's test document txt. And what we also need from the other side, it's like a TMP consumer. And here we expect to copy this one to this folder, right?
Yes, we can use this as the destination when we're requesting the file then.
Great, okay. In this case, TMP provider is fine, right?
No, we need to add the file at the end as well. So the file name must be part of the path. So it would just be test document now at the end. But then it's fine. As long as this file referenced by the path exists somewhere in the system, this should be good.
But without a .txt, right?
No, with a txt, because it will just read this exactly and try to locate that file. So if it's just looking for test document, it might just not find it. And then the second thing that we need to set here on the provider side is this webhook address property. And this, because our provider is the one running on 8081, is just the provider's own URL. But we require this during the contract negotiation, because all of this is an asynchronous progress, and consumer or provider might have to contact each other later on again. We're using this webhook address. So when the consumer initially sends a message to the provider, it will send its own webhook address there, so the provider can later on use that to contact the consumer. So we can leave this as is here, but it's important that we set it.
So the consumer should run on another port, right?
Exactly. That's the first thing that we're setting here. So we're setting it to port 9091 and setting the webhook address accordingly. And then the middle property here is basically just our authentication for the control API. Because as I mentioned, we're going to use one endpoint from the control API, but this is secured by API authentication. So later on, when we're going to use that endpoint from the control API, we're going to have to supply this value password. But that's why we're also setting it to password here, so it's quick to type and easy to remember.
Great. But it's just a mock-up, right?
Yeah, so I mean, I think this is a normal authentication that you have for the API. So I think it's the API key authentication that's implemented there. But we can override this here.
Is that the mock?
Yeah, though this IAM means the identity provider that is used by the connectors so that they can authenticate to each other or other participants in the data space. While this password is just for us as a user to identify to the connector. But this is really just within the in the limits of the connector. So this is not for the whole data space.
Understood. Okay. So let's go there. So I think on the left side, everything is just described as a provider connector. You see here, consumer connector on another side. And then we have to go to run sample. And what's very helpful with the with this one here, you can use EDC file transfer. And then you can split up. So we have left then consumer, provider. Oops. And then we need a third one. Sorry. We need to split the tab again. And here we need to call the service. Okay. So it's clear. So first step is Gradle W sample. Wait. Need to run here. It takes a minute. Then we have to wait for the other ones. So this is now the consumer. Here on the right side, I will build the provider, and here we'll start this. So let's read a little bit about it, run the sample. We say, okay, build the consumer, run the Java for the consumer. In another terminal, I build the provider and start the Java process for the provider. And then we initiate the contract negotiation and start a curl in the third terminal. Okay. That's right, Vanja, right?
Yes, that sounds good.
So the next one. We are ready here. So wait a moment. If you have any question, don't hesitate. I see Thomas, do you need to get a contract for each transmission?
Yeah, so question is if I need to have a new contract. So I just tried it out and I think I made some mistakes. So the file wasn't transferred, so I tried it again, but it seems that the contract has been kind of, well, not expired, but already used. So I need to establish a contract each time I want to transfer a file.
So I think actually, if it's the same file that you're requesting, so each contract is of course always bound to certain assets. So you can't just use a contract to get a completely different asset. But as long as it's the same asset, it should be valid until it expires. And I think we're not setting the end date currently for the agreement, so it actually shouldn't expire, I think.
Okay, so I have to retry. Okay, thank you.
Need to wait some seconds. And the consumer is built very soon.
Ronja, while Matthias is building this, may I ask one question while I'm here?
Yes, sure.
It is a basic question. I see that here we implement a file transfer extension, which is based on the pure Java programming. my very naive expectation was that this extension will be part of the EDC. So I just have to configure, for example, the directory of the provider and the consumer part, and then not relate on such particular parts. Of course, this is for example purposes, but what is the expectation of the core base which we can build on in order to provide such further extensions of the code?
Yeah, so I'm not entirely sure which transfers we want to cover by default, but I think, for example, an HTTP transfer, we're going to provide the extensions for that out of the box. And currently, I think there is something with cloud transfer going on too. But in general, there will be a few communication protocols basically that we support, and then it depends on the use cases or implementations from others to enlarge this. But since we're currently working on the data plane enhancement, I think this might also change a little in the future in regards to what interfaces you have to implement then.
Okay, so it's just a matter of maturity. We have to, of course, be sure that this is a project we started mid of past year. So it is just a matter of maturity. When the maturity grows, then the core base will go up.
I believe so. Like I said, I'm not entirely sure in what detail will cover, for example, different protocols, but there will definitely be some example implementations.
Okay, thank you.
Okay. Also, I see the answer of Markus in the chat. He's pointing out to the specification of the data management API. Markus, do you want to tell us a little bit about the roadmap session we are currently defining?
So finding the unmute button. I can elaborate on that, but basically this was the session before lunch, right? So basically there's information available. One key topic that the current contributors, committers of the EDC are working on is this data management API. Exactly the issue that you opened right now. And as you can see, this is milestone 2 for scoping. So basically really discuss and define what needs to be done. And then basically, of course, one of the follow-ups will be the implementation. So right now, it's, as we saw, you can, of course, add assets, for example, but not via so not dynamically via API. But this is so basically in the scope and will be implemented soon. So if you have any requirements, like always, so, told that already. Sometimes today, feel free to contribute, feel free to discuss, feel free to add requirements. So basically process is started, and at least you can get the information you need out of these issues.
Markus, as I understood, the speed of the development of the EDC getting higher and higher, and now the number of developers increased dramatically now this month, right?
Yeah, that's true, because we have organizations that now staff some of their developers driving specific features. And basically, this is also something I referred to. Of course, you need some kind of sponsor for different topics, that there is the drive and the prioritization of these kind of things. Of course, the management API is something like it's basic, and that's why it's important, that this is why it's addressed now in the next milestone. But there might be other features that are interesting for I don't know, single organizations, single initiatives, and of course, if there's a contribution of these organizations and initiatives, the prioritization is higher, and we can bring that into the code earlier.
Mm-hmm. Great. So there is one hand up. I need to check.
Yes, hello, Philip here. I have a question. If the code is also still building, it's a follow-up basically on what Thomas asked about the let's say, let the persistency or the validity of the contract that is being negotiated. And the question basically is if two partners want to exchange similar data, I'm not talking, not same data, but the same structure, let's say, I don't know, GPS information, but in various periodic times, let's say every day they want to exchange some data. Is there any way to assign this or define this in the contract so that you have to negotiate it once and it is valid for all the transmissions that will follow? Or do you have to do it every time for a specific data set, basically?
So for every set of data, every asset in that sense, you need to create an own contract offer. So you cannot reuse a contract offer that's been made for one asset for others. Though I'm not entirely sure if we allow adding more assets than one to a contract. I would have to check that.
Okay, so you need to have the data available. It cannot be defined for some data that will be available in the future if you know it.
No, because each contract that's made references directly the asset. So if the asset doesn't exist yet, we wouldn't have a valid contract.
Okay, good.
Okay, so we built now the consumer, as you can see. So let's start the consumer on the left side and also start the provider on the right side. So should be the provider here. Copy this. Provider, yeah. So as you can see. So now the provider start on the right side. You can see the left side start the consumer. Need to wait, and then we start setting for key. Hopefully this is right. So that's listening on port 8181. It should be here 9191. Right. Okay. Let's go back to the example. You scroll down.
Yeah, and so the next step that we're going to perform now is the contract negotiation. So if we think back to the sequence diagram, normally we would have to make inquiries about the provider's offers in order to get their contract offers and be able to use them as the input for the negotiation. But to keep the number of steps here as small as possible, and since we've defined the provider ourselves, we know what the contract offer looks like. We've added this contract offer.json in the samples directory. And this we can just use for our request to the contract negotiation. So two down from
Okay.
resources. Yeah, exactly. And in here basically is just the JSON representation of the contract and asset information that we added in our transfer file module. So basically, this is the same objects, just serialized to JSON here. So we've prepared this already here so that we can use this as the input for the contract negotiation and don't have to write our own JSON now or request them first from the provider. And because we have this file in place, we can therefore immediately start with the negotiation.
Great. So let's go here.
So one question, in this case, can you go back to the contract offer? It's the name of the file is text document or test document or test document.txt, because we named txt, I guess.
You mean in the configuration properties? There, I think it has to have txt at the end.
So it's in the. So it doesn't matter what's in the contract.
No, in the contract here we have the asset. So because we named we gave the ID test document to our asset, we're actually referencing the asset here. So we now did this for clarity here that we named the asset ID the same as the file, but of course they might be different. So we could name the asset test document, but the file is just document.txt. But here when we're referencing, we're really referencing the asset's ID. So basically saying the target of this policy is an asset with the ID test document.
And sorry, where's with this mapping defined that this test document is test document txt?
That's what we set up in the transfer file module for the provider.
Okay.
Because there we created an asset that we gave this ID, and to this asset we added the data address that references the file from our settings.
Okay, thank you.
You're welcome.
So let's start it.
Then let's start it and run the first command to initiate the contract negotiation.
What we need is a contract offer, right?
Exactly, but since we have this contract offer JSON, we don't have to change anything here because this is already the correct contract offer for the provider. So we're simply making now a post request to our controller / API / negotiation, and we're giving the contract offer in the request body. And then at the end of our URL, we're specifying the connector address, which is the second input parameter basically we need from the user. And this is just the address of the remote connector that our connector should contact. So 181 is our provider, and this API / IDS / multipart is just the general endpoint for all multipart messages. In our transfer file and in the API controller, we hard-coded that all communication should take place via multipart. So the request has to be sent to this address so that it can be processed correctly.
Is there any difference where I start the curl so I can?
No, that shouldn't make any difference because it just contacts your local host. So directory shouldn't make any difference.
Let's start it. Couldn't read data from file.
Oh no, it's true. We're referencing the file path. I totally. So we need to be actually either in the main directory of the connector, or we need to adjust the file path.
Right. I remember projects. So here we again. So, and this should work now. And we get an ID back, right?
Exactly. And this UUID now is the ID of the ongoing contract negotiation. Because this is happening in the state machine, it's being processed in the background while we already got the response. And we can now use this UUID that we received and call an endpoint of the control API, which gives us information about the current state of the ongoing negotiation. I think this should be the second command in the README now.
So when I'm going back now to IntelliJ.
Yes, if you scroll down a little, there should be, I think step 3 probably, look up the contract agreement. Yes, and this in this we're using an endpoint of the control API. That's also why we have to specify this header X API key and give our credential password. And then we're using the endpoint for the negotiation state. At the end of this curl command, you see this UUID in curly brackets. This we have to replace with the UUID that we just received from the previous call, because then we get the status of the negotiation with that UUID, and in that we can see whether it's finished already, and we can also see what contract agreement has been made there.
There's a full ID here, right?
Exactly, this whole thing.
So let's go back here and say parts, paste. This should work now, right?
Exactly. If you just issue it like that, you should get quite a big JSON string. Now, as this is not really readable on the console, I always put it into an online JSON formatter just so that we can actually see what's in there.
Let's do it. This is a little bit strange here, right?
Yeah, this
is.
Oh no, but above that is, I think, the real response. I don't know why it was printed a second time. Right above that is the whole JSON string, I think.
Right, this one. Yeah.
Yeah.
I see it. It's like a JSON beautifier.
Yeah, if you just, I think, Google JSON formatter, you will get some results.
Find that. Yeah, this one, right. left side.
Exactly, and then we just go for this format/beautify.
But there's some errors. That's
I think, oh, there's something missing at the end. Could it be that the response was just split in your terminal, that we have to actually add the second part after the first one?
The two curly brackets are missing at the end after the null.
Let's check. Ah, right.
This looks complete, actually.
Yeah, looks better. Oops. IDE is a little bit slow. So now, try it again.
Yes, this time it should hopefully work then.
Not really.
So I think you just press the format beautify again, or because I think it just didn't update yet.
Yeah, wait. There's something.
It's still okay.
Tab space. You need to check later. So it was something.
Okay. Yeah, so normally this works. I'm not sure where the error is in that JSON. But we should be able to find the contract agreement as is. So somewhere in there, it should read the property contract agreement.
Yeah, but as you can see here, the property agreement, as you can see.
Yeah, we need the agreement, and then from that, I think it's the third line from the top. In there, I see contract agreement.
Beginning was 1:44D027.
Yes, exactly.
Oh, yeah, I see here.
Yeah, so the first one, and there we have the ID, and we copy that whole ID. So this one colon and then the UUID. The one also has to be included there, so the one colon.
What I should do?
So copy the UUID, but also the one and the colon in front of it. So this whole thing, basically. We will need that in our next curl command because we have to reference the contract agreement there.
Okay.
And as soon as, so maybe because we couldn't see the JSON now actually, so this is basically all the information that is currently available about this contract negotiation. And as long as no agreement has been reached, the agreement in there will be null. Oh yeah, there we have it actually a little better. So because there is this date property which reads 1200 here, but the states are always only represented as ints, so they're not directly readable. But you can just check this contract agreement to see whether the negotiation has finished, because only if it's completed successfully will we have the agreement here, otherwise it would be null.
Okay, so we have this contract agreement here, so it's done, right?
Exactly. That means negotiation was successful, and we can request the data now using this contract agreement.
Okay, so we need to make this curl, right?
Yes, and there we then have to exchange two things though, because there we have once the contract agreement placeholder, but we also have to specify in this request where we as a consumer want the data copied.
So we need this one, right?
This one we'll need in a moment, exactly.
So we need to copy as well. Right. We need to copy the curl now, right?
Yes, exactly, the whole command. And then we can adjust it in the command line.
So we need to do this one.
Yes, exactly. So that we use instead of this agreement ID in curly brackets at the very end. And then the property before that now reads destination path on your machine. Yeah, I think the transfer will not work now because we didn't override the destination path. In the curl command, it reads destination is path on your machine. And this one we will have to.
Yeah, right. Case.
It looks like our extension cannot handle the case when the path is non-existent and can't be created. So I think we have to actually restart the provider there.
Try to stop it. Okay. And here.
So and in here,
Pass to your machine.
exactly, and that we need to specify by some location where you want the file copied. So for example, the temp consumer folder here. It's important that you also add a file name at the end here because it will try to create that file, a file with that name. So if the file name is missing, I think it will also fail.
It works when you have it. No, you don't need a file name. I just made a trailing slash and it created the file.
Okay.
Okay, perfect, perfect.
At least for me.
This one. Okay.
Okay, yeah, that's good to know. I wasn't exactly sure about the capabilities of our file transfer there, but very good. All right. Now, once the connector is up and running, because we're using in-memory stores, we will also have to perform the contract negotiation again. Because we restarted the connector, the stores have been reinitialized, and therefore the contract agreement is gone. So we will have to execute steps 1 and 2 again in order to make this last call.
Okay. Right. Yeah. Good. A little bit lost because I split up my request over 2. So let's go back. We need.
So first we need to trigger the contract negotiation again.
So I think step 2, this
Exactly.
Right. So yes, here. Okay. Then we need on the same boat. So sample, localhost. I think it's done now.
Exactly. In this one, I think we don't have to change anything. And then here we just get this UUID back with which we can get the negotiation status then.
Let's go to the next one. The third one here. With a password and the UUID. Let's go there. Okay. The UUID is here.
Exactly, and that we just append at the end of the URL.
Okay. So now we get the agreement ID.
Exactly, and then we just add this to the last curl command with the path changed.
Okay. Let's scroll down. Then we need this one here.
Exactly.
The agreement ID.
Yes, we need to replace the agreement ID and the destination path in here now.
Oops. Again, I didn't copy that. Hopefully now. Yeah. ID. Remove the agreement ID and copy this from here. A little bit blind here. The agreement ID, yeah, here we are.
Yes, that looks good.
Need to check if everything is fine.
No, the path on your machine still has to be replaced now.
That was TMP, and I think the consumer, right?
Exactly.
Don't need.
No, I think it should then copy the file under the same file name as on the provider side if you don't supply this.
A little bit hard to read here. I cannot move that. Okay. To the end. Okay, good. Let's try it again.
Yes, this time we should then see a different result. So again, we get a UUID back now because like in the example with the contract negotiation, the transfer processes are handled by a state machine asynchronously in the background. But because for a file transfer within the same file system, we don't require any resource provisioning or anything else of that kind, it's really quick. And if you take a look at the consumer and provider logs now, you already see that the provider says it's copied the file and the consumer says the transfer has been completed. And that means you should now be able to access the test document txt in your temp consumer folder.
Consumer. Temp consumer, and then a test document. Or let's check if it's there. Log files never lie. Less, and then the same tmp/consumer test document. So.
Yes, and this should now have the same content as your original file.
File. I don't know why. No. Great.
Yeah, I have a question. Any idea? I was now able to kind of follow the sequence and try it on my side. I'm getting error processing transfer requests, and I'm not sure. Any ideas what it could be?
Okay. Does it give any additional information or just that there's an error?
It just gives this severe error processing transfer request setting to retry and gives me just trying to retries on the.
Okay, are the folders in which your file is and the specified as the destination, are they accessible, or are they, for example, do you need sudo rights to get in there? This might also be a problem,
okay.
maybe.
Yeah, check that. I need to check that. Okay.
All right. Yeah. I mean, if you just put it, for example, on the desktop and also specify the desktop as the destination and try it once, okay. Because there shouldn't be any restrictions, then it should work.
Okay.
Otherwise, we can look again.
Okay, thank you.
So there's also Thomas has a question. For the first one.
That was okay. I need to.
And I have an understanding question. So remembering your picture at the beginning, Matthias, user, consumer, provider, different parties, owner, of course. So in your three parts of the terminal, left was the consumer, upper top was the provider, and the user was below. So in this case, I have to know both, because the consumer is my window to the IDS world, and of course, in order to request a particular asset, I also have to know the provider of this. Is this correct interpretation?
Yes, that is correct.
But it is definitely not so that user and consumer should be collocated. So I could be a user on my machine, and my consumer could be, for example, AWS.
Yes, of course, that's also totally viable. Maybe also to get back to these roles here. So while we have the data user and data consumer as separate roles, most of the times they will be assumed by the same entity. So typically the data user is the one, or if you're going to the provider side, maybe it's a little easier. So the data owner is just the entity that produces the data, well, owns the data, executes the control. And the data provider is the role that's responsible for technically making it available in the data space. Now, in most cases, the entity owning the data will also be the one providing the data. But for example, if a different company than the one producing the data technically manages this, then you might have different roles. But in most common use cases, you will have data provider and data owner assumed by the same role, as well as that you'll have data user and data consumer assumed by the same entity.
And now coming back to my previous question, when I put as a data user this file on my AWS account, obeying the policy that it should stay in Europe. Okay, this will be in Europe, but I imagine I have an Europe account, but I'm sitting in China. In this case, then I further copy this file local to my machine, and the policy actually is not able to prohibit this. Is that correct?
Yeah, so in general, there are a lot of actions that a consumer could execute with the data without the provider knowing. So there are a lot of these things you can do. That's also why this policy enforcement is such a complex topic, because most cases there are really a lot of details that you have to regard to see if this is really accessible. So I think for the moment, I can give you a really good answer on how we could go around this, but I think we will put a lot more thought in that in the future.
Yeah, I can give you one answer because I'm in example 5, and we have just 10 minutes left. We build this example that we transfer a file from AWS to Azure. So what you can do here, we are not implementing that here, but there are some policies in place. You can define the policies in Terraform, for example, and you can define policies for AWS as well, Azure, that you cannot create like a S3 bucket or Azure storage in a different location. So, but this is a specific implementation you will do on the provider or consumer side. So you have to implement the policy, the details about it. Yeah.
Yeah. Okay. It has to be under control of these policies, which have to be copied and enforced at the place. Of course, everything should be under the control of the IDS network. Otherwise, if I leave it, then I'm free to do anything.
Yeah.
So, sorry, I have a quick question related to this and related to the sovereignty. It's not clear for me, how do you encrypt the data? Do you use the built-in cloud mechanism, or do you use an extra dedicated cryptographic libraries that would use not the key management system coming from the cloud?
Mm-hmm. So I think you have different kind of encryption, and if you see on a cloud side, we have encryption in REST done. Yeah. We do that with HTTPS. Encryption and encryption in transit, encryption in REST. You have two possibilities. One is the provider encryption. But this is transparent, or you use your customer managed keys, but this one is not implemented yet. So if a customer needs a customer managed keys, we need to implement this.
Okay, so you have an interface allowing to provide to plug in a kind of specific provider if you want, and to use the key management system of that provider.
I think under extensions you can do that. If you, for example, if you have AWS S3, you can have different data operations and implementations here. Mm-hmm.
Okay, thank you very much. Yeah. Okay.
Okay. Any other question? I think we have some minutes left, so maybe also Peter can post the link to the discussion channel. I will stay here if you have questions, and we can run together the rest of the samples. So we have. We are done, I think, with the file transfer. Let's check. Yeah.
Yeah, we're done with that. Once the file has been transferred, this one is done. Maybe to give a short idea of what these next two samples do. So, I mean, sample 5 is pretty self-explanatory. We're still performing a file transfer, but in the cloud. but the samples for 1 and for 2 introduce additional ways that we can either react to state changes within a state machine. That's what we have with this listener in the sample 4. So here we're basically learning how we can create a class that is notified whenever, for example, a transfer completes or whenever a transfer is moved to the error state. And we can just react to these state changes. And then the following sample 4.2 shows us how we can use the so-called command queue in order to, in a thread-safe way, modify a transfer process that is within the state machine. So maybe just as a short outlook, what we haven't covered so far, but these are again rather small as compared to the file transfer sample. So I think between 3 and 4, we have the biggest jump in here that we have.
Yeah, and it's the same. You need a consumer, a provider, and a trigger, right?
Exactly. So the sample 4.1 also just reuses the provider from sample 4.0 as is and just adds this listener to the consumer side. And then the sample 4.2 doesn't actually use 2 connectors because it just simulates a transfer process that should be modified from the outside.
Mm-hmm. Can you point to the use case for this modified transfer process?
So the example that's used here in this README, and I think it's also probably a very common example. So we have our transfer processes in the state machine, and they're advancing through the states. And if we now have one transfer that's moved to the in progress state, so meaning that it's ongoing, but then for some reason, the state machine cannot determine if it's finished. So it uses just the status checkers to see, is it finished or is it not? If it's finished, I'm doing some action, but if it's not finished, I'm just leaving it in the state machine in that same state. Mm-hmm. Now, if any unforeseen error happens during the transfer, so that it will never be able to complete, but the state machine can't pick that up because it just checks whether it's ready, we would indefinitely have this transfer process in the state machine. And now if we have this with a couple of transfer processes, we at some point will have quite a large number of transfer processes that will forever run in the state machine. And of course, this is something we do not want. So the idea that we are introducing here in this sample is to use something like a watchdog pattern. So we have this so-called watchdog running on a separate thread, and every 1 or 2 minutes or so, checking the next transfer processes, whether one has been in the progress state too long. So far, that's a pretty simple thing, but now we get problems because we have then the watchdog and the state machine itself running on different threads. And so if the watchdog would fire right after the state machine said, okay, the transfer is complete, then these changes made by both would override each other. And in the worst case scenario, we might have completely undefined states or even an invalid state in the state machine. So we cannot use this watchdog as it is and run it on a different thread. So that's basically the problem statement why we want to use this command queue here. And then it basically just shows how commands can be used to let the state machine itself execute the actions so we don't have any problems in concurrency.
Perfect. Okay. And the example 5, that shows how can communicate or transfer files from one cloud provider to another one, right?
Exactly. So this is basically the more sophisticated setup for the sample 4, because in sample 4, we just transfer the file within the same file system. And here in sample 5, we're still just transferring a file, but this time this file will be, I'm not sure if it's from Azure to AWS or the other way around, but this time the file is actually transferred between cloud storages.
In this case, you need a Azure login or account, and you need an AWS account. So okay, can you hear me?
Now, yes. Thank you so much.
Okay. There's a feedback loop. Okay. There are some questions. Philippus, you have a question?
Yes, thanks a lot. Yeah, first of all, let's say thanks a lot for all the demonstration. It was really nice to see all of that. I have a question about discovering, like the partners basically discovering each other. And in this case, we know that it is on port 8181 and 9191. I don't know how it works exactly in the cloud setup, but in a real life scenario, I remember also one sketch that you saw, there is a broker in between, right? Which is basically somehow matching these nodes with each other. Is there any documentation or code for the broker or how it will be implemented? Can you give some rough idea about that, how it works?
So at the moment, I think we have not implemented the broker support yet, but since we've done this in the Dataspace Connector, so the previous project, I can maybe tell a little bit about that. So the IDS broker also uses IDS multi-part communication, and therefore the connector can use the same types of messages as it uses when communicating with other connectors. And then there's basically a few different types of messages that we need in order to communicate with the broker. So the first one is we need to register a whole connector. So there a connector sends its self-description to the broker in order to give the broker the information, okay, I'm going to register some resources here. This is my access information and so on. And once a connector is registered, it can start registering resources by sending metadata to the broker. And the broker will then link these to the connector that sent the resources. And now when a potential consumer comes along, it can send a query message to this broker. And this query message could be, for example, give me all the offers that have a keyword weather. For example, if I'm looking for weather data. And then what the broker will return as response to this query message is a list of all the resources that match our query criteria. And then if we find, then we can use this information that we got back to also request the whole metadata of that offers to have a look at them. And because they are also linked to the connector that uploaded them to the broker, we can also obtain the access information of the provider connector then.
Mm-hmm. All right. Yeah, no, that's a great overview. Is there any work on that? Are there any repositories or documents that we can have a look at? Do you know of anything?
So not in the EDC currently, but there is, of course, I think it should also be on GitHub, the broker repository, so for the broker itself. But other than that, I think in the EDC we currently do not have that yet.
Okay, so I have to look through the IDS. Or,
yeah, I'm just looking for the yeah, I found it. So I think it should be this one. I'm posting the link in the chat here. So this is the open source broker development.
All right, awesome. And yeah, I don't know if you sent it also in the chat. We talked about these payments that are defined in the IDS. I don't know if you found anything.
Not
about
yet,
that.
because I didn't have the time to look for it here in parallel, but I've written it down and I will take a look.
All right.
So
great.
I either post it later or otherwise it will be answered with the remaining questions from the chat.
All right, great. That's it from my side. Thanks a lot again for the whole demonstration.
Thank you, Ronja. I also post the link to the panel discussion now with Boris Otto from the Fraunhofer, Uli Hohmann from Microsoft, Kai Demröter from BMW, and Sebastian Steinhaus from IDSA. And thank you so much. So more than 100 developers participate. I didn't expect that. That's great. Thank you.